3 million people in Naples are sleeping tonight. Beneath the Bay of Pozzuoli, beneath 3 million dreams, magma is rising. It has been rising for years. In Wyoming, the geysers hiss above another chamber, quiet for now, but not dead. And 74,000 years ago, on the island of Sumatra, a volcano named Toba decided not to stay quiet. It became one of the largest catastrophes in the history of our species. Today, on episode 1 of Why Our Civilization Will End, we ask one question. Which chamber fills next? I am joined, as always, by volcanologist Dr. James Calder. James, where do we start?
We start with Toba, because Toba nearly ended us.
Nearly?
Toba erupted approximately 74,000 years ago on the island of Sumatra in what is today Indonesia. It ejected approximately 2,800 cubic kilometers of material into the stratosphere. To put that in perspective, imagine Mount St. Helens multiplied by 1,000. Imagine the entire continent of Australia buried under 3 meters of ash. That is Toba.
What happened to the climate?
Volcanic winter. Sulfur aerosols blocked the sun. Global temperatures collapsed by approximately 5 to 15 degrees Celsius. The cold lasted 6 to 10 years. Photosynthesis nearly stopped. Phytoplankton died in the oceans. The food chains on land collapsed. Across Africa and Eurasia, vegetation withered. This was not a storm. This was a season. A season that lasted almost a decade.
And humanity?
Here is the part that should keep you awake at night. According to the Toba catastrophe theory, first proposed by Stanley Ambrose in 1998, our species was reduced to perhaps 10,000 breeding individuals. 10,000. The entire human race, in numbers, was the population of a small village. We survived by fire. We survived by social cooperation.
And the genetics?
We carry their genes. Every one of us. The genetic bottleneck of 74,000 years ago is written into each of our 3 billion base pairs. We are the descendants of those 10,000 survivors. When you look at your hand, you are looking at the hand of someone who made it through the worst day our species has ever seen.
Let that settle for a moment. Now let us travel forward in time, to Yellowstone. James.
Yellowstone is a supervolcano. 3 past supereruptions. 2.1 million years ago, the Huckleberry Ridge tuff eruption ejected approximately 2,500 cubic kilometers. 1.3 million years ago, the Mesa Falls tuff eruption ejected approximately 280 cubic kilometers. 640,000 years ago, the Lava Creek tuff eruption ejected approximately 1,000 cubic kilometers. 3 pulses, each on a continent-spanning scale.
And today?
The United States Geological Survey publishes a monthly update. The most recent update, released in March of 2026, declares Yellowstone at alert level normal. The magma chamber is described as mostly solid. That is reassuring, but in April 2026, seismologists from the University of Utah published new imaging. Their conclusion: magma sources beneath Yellowstone may be closer to the surface than previously thought. The probability of a supereruption in any given year is approximately 1 in 700,000. Low. But 700,000 years is the average interval between Yellowstone events. We are due.
James, why is the probability not 0?
Because a supervolcano is not a discrete event waiting to happen. It is a system, slowly building pressure over hundreds of thousands of years. The chamber beneath Yellowstone contains approximately 10 to 15% liquid melt. The rest is crystallized rock. But partial melt can mobilize. Hotter melt can rise. A country of magma can be born from a kitchen of magma.
And that brings us to Naples. James, can you tell us about Campi Flegrei?
Campi Flegrei, the Burning Fields, is a 13-kilometer-wide caldera west of Naples. It is not a single volcano. It is a volcanic field, a system of craters, vents, and fissures. Last eruption, Monte Nuovo, in 1538. Last caldera-forming eruption, the Neapolitan Yellow Tuff, approximately 39,000 years ago. And since 2005, the caldera has been in what volcanologists call a bradyseismic crisis.
Bradyseismic?
Slow ground deformation. Hundreds of micro-earthquakes per month. Approximately 60 centimeters of cumulative ground uplift over the past 2 decades. The rocks beneath the city are shifting. They are breathing. And the breath is pulling the floor upward.
What is happening below?
In early 2026, a team led by Luca Carici at the University of Geneva published a study in Nature Communications, Earth and Environment. Their conclusion? A critically pressurized reservoir containing potentially eruptible magma is present today at approximately 4 kilometers depth. Not 8 kilometers. Not deep inside the mantle. 4 kilometers. Beneath the streets.
4 kilometers. How many people live above this reservoir?
Approximately 500,000 people in the official red zone. Approximately 3 million in the metropolitan area of Naples. 3 million human beings sleep above a reservoir that is, in the author's own words, critically pressurized.
What is the probability, James?
The eruption probability has been revised. Some models place it as high as 25 to 35% on intermediate timescales. That is a 1 in 4 chance. Not in a million years. In our lifetime. And the Stanford University 2026 study confirms rising pressure in the underlying geothermal reservoir. The pressure is not stabilizing. The pressure is increasing.
Could we evacuate?
Italy has evacuation drills. 500,000 people in 72 hours. 500,000 people on narrow roads across the Apennines without mobile signal because of the very earthquakes that triggered the evacuation in the first place. 3 million more would have to follow. There is no clean rehearsal for this. There is only the hope that it will not happen on a Tuesday morning at 9:14 a.m.
Let that settle. 3 million people. Tucked beneath a chamber that is, in the words of the science itself, critically pressurized. Let me take a breath.
What stays with me is the difference between the chamber and the city above it. The chamber does not know there is a city. It does not care. It is geology, and geology is incomprehensibly patient. It will outlast us. It has outlasted 10,000 previous species. It will outlast us too, unless we listen.
Thank you, James. That is where we leave episode 1. Next week, we turn to the oceans. The Atlantic current known as the AMOC appears to be weakening, and the orbital cycles of Milankovitch are pointing us, slowly, toward the next ice age. We will ask, could a climate collapse arrive not by warming, but by cooling. Until then, sleep well, stay aware, and remember, volcanoes do not ask permission. They do not warn twice. Which chamber fills next is geology's choice, not ours. Good night, James. Hold. A last-minute update has just come in from Italy. This bears on everything we have just said.
Go ahead, Mira.
On Friday, July 31st, 2026, at 1946 local time, a magnitude 4.7 earthquake struck the Campi Flegrei volcanic area, west of Naples, near Pozzuoli. Shallow depth, approximately 3 kilometers.
3 kilometers. That is exactly where the Carici 2026 paper located the critically pressurized reservoir. The same depth. The same chamber.
What happened on the surface?
Power outages across the metropolitan area. Partial building collapses in the historic center. A pier in Campi Flegrei itself was damaged. Public transport across Naples was disrupted. More than 30 aftershocks followed in the hours that came. Cars were crushed by falling boulders. Residents fled their homes.
Were people hurt?
Reports vary between Reuters, Euronews, and the Italian press. 21 to 26 people injured. 2 seriously wounded. 18 families evacuated. Most injuries to date are from falling debris and panic, not collapsed structures. But the historic center is fragile. Centuries-old masonry does not forgive a shakedown.
Was this the magma?
Not the magma directly. The bradyseismic uplift and hydrothermal pressure beneath the caldera have been building for 2 decades. They deform the crust above. Stresses accumulate along the ring faults. Fractures slip. That is the textbook mechanism for caldera seismicity. The tremor was the rock, not the magma this time. But every shallow swarm at 3 kilometers is a sentence in the slow sentence the caldera is writing.
What does this do to the 25 to 35% forecast?
On its own, it does not upgrade the probability number. It confirms the model is right to put the probability that high. A magnitude 4.7 at the depth of the pressurized reservoir is exactly the kind of event the Carici warning anticipates as a precursor. Not an eruption tomorrow, but a system in motion, exactly where the model predicts motion would occur.
What should listeners do tonight?
If you live near Naples, monitor the Italian Civil Protection Agency and the Vesuvius Observatory of the National Institute of Geophysics and Volcanology. Pack a go bag. Know your evacuation route. Know the nearest shelter. Check on elderly neighbors. The Brady seismic crisis has entered its 21st year. It does not wait for us to feel ready. And if you listen from outside Italy, this is not geographically limited. There are volcanic calderas near you. Auckland, Yellowstone, Long Valley, Tal. The lessons of Naples travel. Pressure builds. Tremors come. The lesson is preparation, not panic.
Thank you, James. That was our last-minute update. Next episode, we will return with the geological implications of a magnitude 4.7 at reservoir depth. But tonight, stay aware, stay close to your family, and remember, volcanoes do not ask permission. They do not warn twice. On Friday, they sent us a tremor. Listen to it. Good night.